Thanks a lot for your interest. Today I will talk about the word Rust Belt. And first, a few words about me. I'm a lecturer in the economics department since 2018 at Essex. My teaching and research fields are labor economics and regional urban economics mainly, but I'm also interested in productivity and technology and political economy. And most of my research is on issues at the intersection of labor and regional urban economics. I'm interested mostly in local labor markets, understanding the causes and consequences of differences across areas in wages, employment, innovation, and other socio-institutional economic variables. So today I will discuss with you a topic at the intersection of labor and urban and regional economics. And this is based on a study joined with Luisa Gagliardi at Bocconi and Enrico Moretti at Berkeley. The big question that I want to discuss with you today regarding the word Rust Belts is the following. What happens at local level after manufacturing decline? So here is our motivation. And before I get into the graph, let me tell you a little bit about the data that we use. So we will focus on local level. So we have data on all the localities in 66 different countries: France, Germany, Italy, Japan, UK, and US. And in this graph, what we do is that we look at manufacturing jobs. We have data at local level. We sum across all the localities in order to obtain a country level number for manufacturing employment. And we set the number of manufacturing jobs in 1970 equal to 100. And then you can see two things from this graph. First, in all the 6 countries, you notice at some point a decline in manufacturing employment. The decline starts in 1990 in Germany and Japan, in 1980 in Italy and France. Instead, in US and UK, manufacturing employment was already declining in the 1970s. Now, I could spend hours and hours discussing the economic, political, even social implication of these country-level trends across the West. Only 20 minutes, so I'm going to summarize it with a quote from a song by Bruce Springsteen, and he sings the following: "Now, main streets, whitewashed windows, and vacant stores, seems like then nobody wants to come down here no more. They're closing down the textile mill across the railroad tracks. Foreman says, these jobs are going, boys, and they coming back." And I think this song, My Hometown, captures the weary feelings of a worker facing what is really the disappearance of a complete way of life following the manufacturing decline. So today I want to discuss 3 pieces of evidence relating to our question of what happens at local level after manufacturing decline. And first, I want to look at heterogeneity across locations in labor market performance. Then I want to look at the type of industry variation that we see at local level after the country experiences the start of manufacturing decline. And then I want to look at the role of human capital and universities. Let us start with the first piece of evidence on spatial heterogeneity. And here the question is there significant heterogeneity in economic performance across local labor markets after the start of manufacturing decline at country level. And I'm going to use the acronym LLMs to refer to local labor markets. The idea of a local labor market, this is an economic unit, and as opposed to administrative unit, and it's basically these local labor markets are territorial groupings of municipalities which are characterized by some important degree of daily commuting. For instance, if you take Milan in Italy, we don't just look at the municipality of Milan, we don't just look at wages and employment in the municipality of Milan, but we also look at all the municipality around where people may live, people who may then commute in the morning to go and work in Milan. So it's really an economic area, a local labor market. So let's start with a quick look at the data of some cities, selected cities for the UK. You may expect that all the traditional centers of manufacturing decline strongly after the country experiences the start of this transformation. In practice, we see that this is not the case, and I will show you starting from this table. But let me give you a little bit more details. In the first column, you see a proxy for how important was manufacturing in the cities in 1970. MF share, manufacturing share, is the share of the workforce employed in manufacturing. In the second column, you find a proxy for the labor market performance of these cities. And in particular, this is the mean decadal growth rate of total employment after 1970. So basically, what we do is that we take a city like Liverpool, for instance, and then we look at the growth rate in employment between 1970 and 1980, then 1980, 1990, 1990, 2000, and so on. And then we take the mean of this growth rate. And this is our proxy for labor market performance, one of the main proxies. And what you can see here, for instance, is that cities at the top and at the bottom, they all have high share of the workforce employed in manufacturing in 1970, but then their performance is very different. For instance, compare Middlesbrough and Slough, they have the same manufacturing share in 1970, but in Middlesbrough, employment declined on average 18% during this period. Instead, in Slough, it increased by 8%. Now, we can look at this more generally by plotting the distribution of mean decadal growth rate of total employment after the peak of manufacturing by local labor markets. Again, remember that the peak is in Germany and Japan in 1990, and afterwards there is decline. In Italy and France in 1980, in UK and US is 1970. Now, a small point here, you may notice that all these distribution are centered around zero. The reason is that we express the mean decadal growth rate in deviation from the country level mean. So for instance, if you take Erlangen in Germany, and Erlangen, suppose, grew 15% on average after 1970 each decade. Instead, Germany grew 3%. Then for Erlangen, we do not report 0.15, but we report 0.12 because Erlangen grew 12 percentage points more than the typical German place. And what you can see in this graph is that, again, let's stick with Germany for a second. You can see, for instance, that there are cities on the left that decline a lot. They lost 15 percentage points compared to the rest of the country. And this is something that you may expect. After all, we are talking about manufacturing decline, and many cities are going to be affected badly. But you can see also that there are places on the right which experience employment growth. In the case of Germany, for instance, there are cities that experience growth of 10, 11, 12 percentage points compared to the country. And this heterogeneity is present across the 6 countries. Here I'm looking at all the localities in the countries, but the same similar heterogeneity is also present for traditional centers of manufacturing. These so-called manufacturing capitals that have a high manufacturing share at peak. Now, the same way that I made the comparison between Middlesbrough and Slough before, I can make for other countries, just so that you have some names kind of behind the distribution that I showed you before. And I'm just going to briefly mention some of them. For instance, Turin in Italy, this is the home of Fiat, important center for car manufacturing, the Detroit of Italy for this model of production, big economies of scale, a model that worked well until the late 70s, but then entered into decline. You can see the very weak performance of the labor market in Turin. Another example opposite in Italy will be Bergamo, but perhaps something that you can relate more is San Jose, the home of the Silicon Valley. You can see very similar manufacturing share compared to a typical Rust Belt place like New Haven, Meriden, but then very different performance. San Jose grew 13% on average, and New Haven declined 19%. So you can see similar for Japan, Ashigaka, Enagnu, France, Saint-Étienne, Boulogne-Billancourt, Wuppertal, Erlangen for Germany. You can see cities that are similar in terms of manufacturing share at the peak, they then perform very differently. A small fact regarding these cities, you may remember here from previous slide, Liverpool for the UK, and it has now that many of these cities with that are traditional center of manufacturing also have strong tradition in football. Liverpool in the UK, in this table you can see, for instance, Turin, the home of Juventus. I put Wuppertal for Germany, but Dortmund had very similar manufacturing share. Schalke 04 would be another example, and you are too young to remember regarding Saint-Étienne, but at the time that manufacturing was strong in France, Saint-Étienne was by far the best team. So a little random fact, but maybe not so random if you consider that back in the day, there was a much stronger link between the local economy and the finances of a football team, and also if you consider that football is a working class sport. So I discussed this heterogeneity. We are ready to move to the second step. We saw that there are successful and unsuccessful places, but what type of changes we observe in the industry mix for these two sets of places? In order to look at this question, I will define a category of local labor markets, LLMs, of relative growth. These are localities whose performance is above the median, localities that do better than the rest of the country. And here we look at manufacturing employment growth, and we divide into high-tech and non-high-tech growth. High-tech during the period of analysis in the early period will be something like mechanical, electronic, computing, professional equipment. Today will be something like biotech. You can see that places of rapid growth, successful places, lose jobs in traditional manufacturing, for instance, textile, shoe and leather, etc. But then they're able to add jobs in high tech. And similar, if you look at knowledge-intensive services, successful places are able to add jobs in this industry. Of course, as local labor markets add jobs in high-tech manufacturing, knowledge-intensive services, then a process of so-called multiplier effects kick in. Let me give you an example. Consider Anna, who is a software engineer working at Twitter. After work, she goes out for dinner or for a drink, and she supports the job of a barista. She may need a dog sitter. She may need an architect. She takes the taxi. So every job added in the high-tech sector of the economy, in the innovation sector, then creates jobs also in the local services. Now, we see that there is this heterogeneity. We'll also see that there is important industry turnover in successful places. And then the final question I want to discuss with you is what is the role of human capital in the universities? In particular, does human capital have significant power when it comes to explain variation in labor market performance of these cities? So in this graph, I look at the relationship between human capital and labor market performance after the peak. We measure human capital at the peak of manufacturing. So our proxy for human capital is the share of the workforce with a college degree. And this is on the x-axis. Notice again that this variable is expressed in deviation from the country mean. So for instance, if San Jose in 1970, San Jose in the US in 1970, has a share with college degree equal to 35%, and the US in 1970 has a share with college degree equal to 25%, for instance, then for San Jose, we report 0.10 because San Jose has 10 percentage points higher share with college degree compared to the US at the peak. So this is what you see in the x-axis, both on the left and on the right panel. Now, on the left panel, on the y-axis, you find employment growth. Again, measured by the mean decadal growth rate of total employment after the peak of manufacturing. So if you are looking at Japan, for instance, we have on the x-axis the share with college degree in 1980 for each of these local labor markets, and on the y-axis, the mean decadal growth rate of total employment after 1980. And each blue dot is a subset of local labor markets with similar values for the x-axis and the y-axis. So, and the red line is the best linear fit estimated on the underlying local labor market level data. On the right panel, instead, we have the mean decadal growth rate of wages after the peak of manufacturing. What you can see overall on the left and on the right is positive association between our proxy for human capital at the peak and the labor market performance of these local labor markets after the peak. And in particular, if you are curious about the numbers, a 10 percentage points increase in the share with a college degree at the peak is associated with a higher growth, in particular 8% higher growth in employment post-peak, and 4% higher growth of wages. Now, a final related question is whether we can think of a variable which predicts human capital at the peak. And we know that individuals raised in local labor markets with a nearby universities have higher levels of education. So here we decided to study the role of university proximity. So what we did is that we look at each of our countries, we look at the year of peak of manufacturing, and then we went back and see we look at the presence of university built up to 20 years earlier. For instance, take UK, actually US, maybe the peak is reached in 1970, and then we go back to 1950, 20 years before, we collected data on the universities built up to that point. We collect information regarding the exalocation of the universities, and then for each local labor markets, we calculated the distance from these universities. So again, that we try to explain the human capital of a particular local labor market in the US in 1970 as a function of the proximity to universities built up to 1950. And what you find is that proximity to universities has significant explanatory power, both when it comes to explain human capital and also when it comes to explain performance. I don't have time to get into the details here, but if you're curious, the relevant concept is the concept of an instrumental variable. We use university proximity as an instrumental variable for human capital, and at the end of my slides, I added some references. So let me conclude now. What have we learned? I hope we learned something, even if we only had 20 minutes. I show you evidence that there is large heterogeneity across areas in labor market performance after their country enters into a phase of manufacturing decline. We also discuss how successful places have important turnover, in particular, they lose job in traditional manufacturing and they have job in the innovation sector. Also, we have to keep in mind that the 1970s and 1990 was a process of important transformation in the West. And today I show you that human capital and the presence of a university have significant explanatory power when it comes to try to explain variation in performance. Once again, the period between 1970 and 1990 was a period of deep structural transformation, and the West was transitioning from traditional manufacturing towards innovation. Today, with COVID-19, we are potentially again into a period of deep structural transformation. Now, our evidence for the world Rust Belt strongly suggests that the skills are very important for these localities to be able to reinvent themselves. More in general, I think that our estimates have relevant policy implication because they strongly suggest that a period of transformation, the worker skills are important for the local economies in the task of reinventing their industries, their labor market, their local economies in general. Thanks for your interest.